Right, here's a centre of mass question from Edx M3 Jan 2010, question 3. And this one looks a little bit off-putting. It's quite a long question. There's actually two parts to the question. This is the first part, to show that the distance of the centre of mass of this object from O is this much. So take a moment to pause the question and read it. It's all about a solid hemisphere having another solid hemisphere removed from it. That's the first part of the question, and then it goes on to the second part, which is about, again, pause it and read it. There's a second mass attached to a point P here, which tilts the thing over, so it's resting on a horizontal plane. There's a mass of km there, and the centre of mass of the whole thing we know is somewhere on this line here, and we found that in the first part. So let's get cracking. I've got both parts of the question down on here, and I've already done some preparatory work on this. With all these questions, you just have to take care working out the masses and the distances. And the first thing I'd like to do here is to just pause the video and check that the masses are in the ratio. As I've said on here, the masses are in the ratio 8 to 27. Just check out the volumes. You can see that the two radii of the hemispheres, the smaller hemisphere's got a radius of 2/3 r, the larger hemisphere's got a radius of r. So the ratio of the radii, that's a bit of a mouthful, is 2 to 3. So the ratio of the volumes, which we're going to use as the masses, is 8 to 27, 2 cubed to 3 cubed. And that simplifies it. We don't need to have all the r cubes and things in the table. So the big hemisphere mass 27, the little one 8, and what's left when you remove the little one, 27 minus 8 gives you 19. So in this table, the idea is the small hemisphere plus the bowl, which we've got with the hemisphere removed, put them back together and we get the whole thing, the whole big hemisphere. In the second line, check these carefully again. We're putting in the distances of the centres of mass from, and I'm doing it from the line through O. For a solid hemisphere, the distance of the centre of mass is 3/8 of the radius below the centre. So again, just check those values, and we're trying to find x bar, the distance of the centre of mass of the bowl. Okay, once you're happy with those values, all we have to do is the usual moments. So the moments of the whole thing is made up of the sum of its parts. So what we're going to have here, 8 times 3/8 times 2/3, that's a quarter of r. That's the moment for the small hemisphere, plus 19 x bar, the moment of the center, the mass of the bowl, is equal to 27 times 3/8 r. All we have to do is rearrange that now, and that'll give us x bar equals 65 over 152 r. And that's the first part done. Oh, it says show that. Yeah, show that the distance is. So 5 marks for that. While we're on here, the 5 marks were allocated in this manner. For the masses, you've got to mark for getting the correct masses, and for the distances, you've got to mark in the table. For attempting moments, you've got a method mark. For the correct terms and for the answer, you've got 2 accuracy marks. Okay, second part of the question. Again, I've added some lines to the diagram. What we've got is a mass of mg, that's the bowl mass there, from the first part, and we now know x bar. Okay, x bar was 650152. I'll just jot that on here. 650152r. Right, they tell us this is angle theta down here, and they've told us the tan of theta is 4/5. So again, make sure you've read the question before carrying on with it. Alright, we've got basically the contact point between the sphere and the ground is here, and the reaction would act here, up here. Let's take moments about that point then. Moments about the line OC effectively, or moments about C. Now, these distances, using my little magic wand again, this distance is x bar sine theta, and this distance here is r cos theta. So double check that, perhaps pause the video and check. I'm doing moments about C, and we're going to get mg x bar sine theta must equal kmg times r cos theta. That says cos theta, it's got a bit wrong. Cos theta. Right, the mg's cancel. Let's divide sine by cos, so we'll get x bar tan theta equals, the mg's gone, x bar tan theta equals k, kr. X bar is 65 over 152, so that goes in there. 65, apologies, my pen is playing up a bit. 65 over 152 r, that's a 5. Don't know what's happening here. 65 over 152 r times tan theta, and tan theta is 4/5, equals kr. So the r's now cancel out, and we get k equals, it comes to 13 over 38. Again, some issues with my pen here. 13 over 38. That's a 38. Apologies if it looks a bit, I'll leave it as it is, but 38. Yeah, let's change it. Right, and the marks for this bit, I've jotted them down here. For a diagram showing how it's resting, a method mark for that. For putting the mg and the kmg and the x bar and the thetas in to show the values on the diagram, and you've got another accuracy mark, another 2 accuracy marks in there. For taking moments, you get a method mark, and for finding the correct value of k. So basically 2 method marks, 3 accuracy marks. The method marks were for the diagram and finding the distances, and for the moments, and the accuracy marks were for basically getting the right values in the right place and finding the right final answer. Okay, thank you for listening.